Good afternoon, Bapak, Ibu, Saudara. My name is Raras, and I will be the moderator for today's sessions. I hope you all are well and have a happy fasting. So we're still in Ramadan, the last 10 days. And today, we are very proud that Department of Information Systems, the Faculty of Intelligent Electrical and Informatics Technology, my name is Sarah, and I will be the moderator for today's session. I hope you are all well and Adjunct Professor, happy fasting. Internet of Things, so we're still in Ramadan, the last 10 days. And so really sorry about that. Perhaps there is feedback noise because we also live for the lecture series Adjunct Professor. All right, so we have 4 sessions in total. The first one is Fundamental of Internet of Things by Professor Shuo-Yan. He is the director of the Center for Internet of Things Innovation, National Taiwan University of Science and Technology. The Adjunct Professor programs from ITS have several aims to activate an international academic atmosphere, to activate the culture of international publication, increase the number of international lecturers and ITS reputations in the world. We have a learning objectives from this lecture series to give a foundation in the Internet of Things, including the components, tools, analysis, not only teaching the concepts behind the IoT, but also we will look at the real-world solutions. So we believe in the future, more and more devices and machines will be connected. So the Internet of Things connect the digital and physical worlds. As a result, we'll automate the business process. We are gladly proud our previous year Adjunct Professor 2021. Hopefully this year we will continue the success. So here is the timetable. So please join all. We have interesting topics for the following sessions. IoT application with data and analytics data integrated to innovative business models and Industry 4.0. So yesterday we have more than 50 participants registered, and this is so wonderful that today we have a lot more, so more than 100, almost 150 participants. They are from Information System Department, Electrical Engineering, and others institutions. So welcome and thank you very much for joining. Just a little bit of class rules. So please use full name in the Zoom meeting, and please kindly turn on your video. Use the virtual background. We will provide it in the chat Zoom, and there is a presence form as well. If you have any question, you can raise your hand or you can write in the chat. I will gladly read it for you. And there will be a certificate of attendance for participants who join all the 4 sessions. And there will be another certificate for you who pass the evaluations. So here the schedule for today. After this, there will be opening speech by the Head of Information System Department kepada Dr. Mujahidin. Dipersilahkan.
Ya, terima kasih. Assalamualaikum warahmatullahi wabarakatuh pada seluruh peserta Adjunct Professor. Good afternoon, Prof. Chou.
Good afternoon.
Okay, I feel very happy in this afternoon. Prof. Chou is willing to give me again about this lecture for Information System Department. Where in this year, this lecture is the second meeting. And then I express my gratitude and appreciation for Prof. Chou. Guest lecture is planned for Prof. Chou will give 4 meetings. Kemudian kepada seluruh hadirin, saya juga mengucapkan terima kasih. Saya harapkan para hadirin bisa mengikuti acara guest lecture atau Adjunct Professor ini ya, sampai 4 kali pertemuan, bahkan ada tesnya ya. Pada panitia, pada Bu Erma, pada Mas Indi ya, terima kasih semuanya. And then finally, in this afternoon, I invite Prof. Chou to give lecture about Internet of Things enabled services. Thank you. Thanks for a lot, Prof. Chou. Terima kasih. Silakan.
Okay. Thank you.
Terima kasih, Dr. Mujahidin. Untuk selanjutnya, for the next speech, we will have the coordinator of Adjunct Professor class kepada Profesor Erma Suyani. Dipersilahkan.
Okay, thank you, Bu Raras. Ya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
First of all, we would like to thank to Professor Chou and also Pak Muja, Mas Indi, Bu Raras, and all of team of this Adjunct Professor program. Because of your support and help, so we can organize this program. For all the participants, congratulations and thanks for joining this program. Thank you very much, and I will return this session to Bu Raras. Thank you, Bu Raras.
Thank you, Professor Erma. So I'm really proud to introduce Professor Chou. He is a distinguished professor in industrial management from National Taiwan University of Science and Technology. He pursued his PhD from Industrial and Operations Engineering University of Michigan, USA. He teaches several courses, including supply chain management, product design development, and introduction to Industry 4.0. He has various research interests, including Internet of Things innovation, industrial Internet of Things, big data analytics, and smart city applications. So without further ado, please welcome Professor Chou. The time is yours.
Thank you. Let me switch the, okay. Are you seeing the right slide?
Yes.
Yes.
Okay, perfect, perfect. First of all, I would still like to, although I think we don't have too much time, but I still would like to say a few things. Thank you very much for the invitation and coordination for the lecture. I think some of you know that NTUST has very close relationship with ITS since a long time ago. We had a lot of, or still have a lot of students from ITS. I think currently I have 4 master students from informatics department, and 1 from electronics engineering department, and 1 from mechanical engineering department, studying their masters with me. They are the main research forces in the lab, helping up with all kinds of development. So for that, I would like to thank the faculty members in ITS for educating great students. For this particular lecture, because it has only 6 hours, I think last year we received some feedback on the content. Some students feels that they also want to know a little bit about practical issues. So this year, fortunately, Indy is willing to help do some demo. So other than the lectures, we'll have some or more practical introduction on the development that we have. We do development, but development has each of the development has a lot of details. If you want to go into one application, it will take a lot of time. So my arrangement with only 6 hours in total will be just as I did more or less like last year. That is, I will try to introduce the key issues, key concept, and key applications, or a lot of process that enable new application or services with IoT. And also because IoT, if we only look at the IoT by itself, it is just an infrastructure. It doesn't exist by itself. It has to work with other technologies, in particular, data analytics. So I will introduce a little bit of the new AI, which combined with IoT can support something called data-driven approach for tackling a lot of, or establishing or enabling a lot of new application. Also, the problem of the trustability of the data nowadays becomes a big problem. One is, of course, cybersecurity issue. The other is whether or not we can trust the contents of data. The data were safely stored in the system, but the data may not be correct, or the data has been safely stored into a system, but it was altered by somebody else. So the data integrity issue is also a very critical issue to support data-driven approach. IoT and these two other digital technologies enable a lot of so-called smart solutions. I will try to link them together so that you will see that with IoT getting data and allowing us to utilize data to establishing application, and these application in most of the places are perceived as smart solutions. Okay, so that's my very brief introduction of the motivation and the contents of this particular lecture. So I have divided into 4 parts. The first part is on the fundamentals. The second part will focus more on getting data, and these data enabling application. And these data need to be analyzed effectively. A lot of data were not structured data. We have them, but we cannot utilize them. Fortunately, with the recent development of deep learning, machine learning and deep learning, I think particularly deep learning, we are able to convert a lot of unstructured data, for example, video data, photos. These data, after being converted, they became structured data so that we can utilize. Otherwise, they are just data, static data. We still require human to process them. But with deep learning, we are able to convert these unstructured data into structured data so that we can analyze them in large quantity and in depth. And the third week, I will talk about integrity. Okay, so integrity and different business model with IoT and AI and blockchain. The integrity will be, and I think it's also a very relevant issue nowadays. The integrity will be supported by blockchain or blockchain-like technologies. And in recent development or recent popularization of the metaverse, blockchain will also be the fundamental technology to support the development of metaverse. In the end, I will be trying to put everything together, again, using a technology that we have been talking about for close to 10 years. Industry 4.0 was first promoted by German government. And at that time, they said that this is the vision of the manufacturing 20 years from then. Now 10 years has passed. Let's see together what development has already been done and what can we see beyond what we have right now. So these are the main contents that I would like to share with you during 4 lectures. Okay, and I think in the end we'll have question and answer session. But during my presentation, if there's an urgent and burning issues that you feel that you need to raise question, you can type on the chat. The chat box. If I see it, I will probably respond that at the right moment. Okay. So the fundamental, I think I would like to emphasize that a lot of technologies have been developed in the history of humankind, but there are certain technology which people perceive them having greater impact than others. There are three big circles here. I think because in the interest of time, so I will probably just show them. The first one is wheel. The second one is printing press. The third one is World Wide Web. If you connect them, you'll find that they have some similarity. They are having tremendous impact on human survival and human cultural continuation and human development. With wheel, we can move large amount of products so that human can survive in different places, not like other animals. With printing press, we can not only record information, we can multiply, disseminate the information in large quantity and fast. Before that, you can imagine that we need to have monks or some other people transcript everything, writing them and writing one after another. But then with printing press, we can duplicate them and produce them quickly, and so that knowledge can be disseminated much faster so that the entire society can grow much faster. So the first technology will allow us to expand our space, or reversely, we basically compress the space for human to be able to survive. The second technology involves how fast our human can evolve. With printing press, more people getting educated, knowing more things, continue to create new knowledge, and it sort of grow exponentially. That also help us to compress the development of any kind of technology, any kind of ideas tremendously. So under this strong time and space compression result in a revolution in human history. Similarly, in recent years, World Wide Web created that effect. World Wide Web connect human all over the world. I think for students nowadays, you probably don't have the feeling because you were born in this era. Everything should be like this from your perspective, but it wasn't. And it wasn't too long ago. The world was totally separated. From Indonesia to Taiwan, to communicate certain information, basically to take a long time, and the communication will be very limited. Now we can just sit here. Everybody is sitting maybe at home, in the office, in the classroom, but we can communicate information directly, and we can do it as much as we want. So World Wide Web fundamentally changed the world, connecting people, connecting knowledge, allowing the society to evolve, to grow much faster than it was before. And if you look at the human history, you look at the technology development, basically a lot of new terminology came out. One of them is exponential technologies, technology which enable exponential growth. So this is our society right now. The changing is getting faster and faster because we are connected. Humans are connected. Our knowledge are connected so that we can aggregate them and reproduce them or create new knowledge. So this is the context. That is, we have a connected world. We have a connected world. Well, so another thing is our connectivity was through a digital means. Without the digital means, in the past, we record everything. This is our traditional desktop. I think for a lot of you, you probably could not imagine that in the past, in order to keep all the information, how many gadgets that we need to have so that we can keep them. But now everything can be stored in the computer. Not only in the computer, now everything can be stored just in a very small device, a smartphone. With this smartphone, we store everything. With this smartphone, we are connected anytime, anywhere, and anybody can be connected with others. In fact, this is tremendous. You probably don't have the feeling, but this is tremendous. We can aggregate these all of the people together using collective intelligence to create even more knowledge, more development, much faster. And this kind of society is quite apparent. Okay? When humans are having this so-called digital society. Later, I will also talk about there are a lot of issues related to this digital development. I think the gradually the value created by human will be mostly digital, and how do you preserve your digital rights? How do you preserve your digital asset? How do you guard your digital sovereignty of a country and so on? These are all very important issues. But let's look at this digital society.
Prof.
You can see that not only
Prof, I'm sorry.
Yes.
But your slide not moving.
Already?
Yes.
How about now?
Still.
It's still not.
Maybe you.
It's still in the first.
In the first one, Prof.
Yeah, you can stop share first, sir, and then you can share your screen again.
Sorry.
Yeah, okay, now.
Now it's perfect.
Maybe slide show, Prof.
Yeah.
How about now?
Yes, okay.
Still in the, not in the slideshow, still in the in the design.
But I think Professor already clicked on the icon, Mas Indi.
Yeah, but it's still in the presentation slide. Yeah, right.
Is this? I'm on slide 7. Is it?
Yeah.
Digital transformation.
Yeah, you're in slide 7, but not in the slide show view.
The view is still not in slides. Yeah. Okay.
Now it's okay.
Perfect, sir. Now it's perfect.
Oh, okay. Okay. You can see it now.
Yes.
Okay.
Yes, Prof.
Okay, that's good. Sorry.
Okay, sir.
This okay. So this slide show you all the relevant data about supporting that we are having this digital society. Basically, a majority of the people are connected, right, through computer, through smartphone, and through social media. And in fact, if you look at the companies in the world, who would imagine that in year 2020, if you look at the top 10, the company having the largest top 10 company, global company, having the largest market cap, include companies such as Alphabet, Google, right? Alibaba and Amazon. They are just online retail store. Right? Tencent, Facebook, well, Microsoft, Apple has hardware, but Apple's profit and services come from service and a lot of other applications. So these companies which only connect knowledge, fulfilling human needs digitally or intangibly, but they have already created mass amount of revenue and profit. This is how the world will continue to go. This shows that so-called digital society is not just a cliche that, oh yeah, we have everything digital, so we connect digitally, so it's nice and it doesn't have value, or it doesn't create value. It does create value, and create value in a major market. However, I would like to sort of change the tone a little bit. Although we are connected, knowledge seems to be connected, humans seem to be connected, right? We are connected, we are talking to each other. But in fact, we are still having a parallel world, meaning that digital world, everything is connected. If you are connected with the digital world, humans are connected with the digital world, humans are connected. But the physical world, if you think of it, the current physical world, it is still separated from the digital world. So what parts of the physical world that need to be connected with the digital world? You can think of, for example, your health. You want to understand your health, but if you are not connected with the digital world, you are not connected, your body is not connected, then all the powerful tools in the digital world cannot help you to deal with your health problem, say in real time, and providing the information to your doctor, and or reporting your exercise to the doctor. These kind of information will not be collected, will not be provided and analyzed. So your health in the physical world cannot benefit from the development of the digital world. Similarly, you can think of, say, transportation or the physical environment, pollution, energy, or smart city, or manufacturing. They are basically, they are physical objects, but they are basically functioning on their own. The data they created disappear. They were not collected. The data of these machines, even though they were collected, but then if you cannot connect them, then you will not be able to utilize the digital system to analyze the data and provide decision support or provide service to these physical objects. So in order to sort of combine them together, I think a very important development has been established over the past 20 years. Is the Internet of Things. Internet of Things. With Internet, we have World Wide Web connecting the world digitally. And there also semantic web. Right now, in fact, Web 3.0 is considered, semantic web was considered the Web 3.0. Of course, now Web 3.0 consists of a lot more technology, but still semantic web is the core. That is, on the web, we are not just connecting pages. We are connecting knowledge together, connecting these data together. You search a specific data, all the right relevant data can be searched. Rather than you search some phrase, here comes hundreds, thousands of pages of information. You cannot process them. So semantic web will be very important. Again, enhancing the connectivity of the knowledge. But as I said, physical world and digital world were separated. Internet of Things is basically connecting physical world with sensors, with the communication, so that the data can be collected continuously and building up models supporting decisions. And also because they were connected constantly, so they can provide real-time responses in case that there's this need. So Internet of Things basically integrate physical world with the digital world together so that the strengths of the digital world can be applied in the decision and the support of the physical world. Okay. Right now, the definition is like that. In the future, it could be quite different. In the future, if everything is connected in the digital world, every physical thing is connected with the digital world. I think for people supporting metaverse, they will consider digital world is the main world. Even physical world will be supporting digital world. But right now, again, at this point, I will still emphasize that we are at the stage that we are utilizing the power of the digital world, trying to utilize the power of digital world to support all the activities in the physical world. I'll give you some cases, examples later on. Another thing which is very a little bit abstract, but I think you can still understand. That is in the digital system, current digital system, okay, excluding blockchain, you can only transfer, you can record and transfer data. You can only record and transfer data. If I ask you, can you transfer, can you record, store value? And also, can you transfer value directly to digital means? I think most of you may say, okay, for sure I can, because I use mobile payment. I use all kinds of digital payment. But that's not transferring value directly, because the data transfer to the other side doesn't transfer the data, the value directly. This information will transfer to a bookkeeper, the bank, financial institution, or endorsement organization. They will do this value transfer to their bookkeeping, their ledgers. But in the digital system, we only transfer the data and allow them to do the value transformation. Also in the digital system, when I said I transfer a certain amount of money to you by email, by line, or WhatsApp, would that happen? Nothing happened unless a physical organization behind it doing keeping the ledger, doing the transfer for you. In fact, they are also recording our value for us. So even though we have digital system, we can connect to anywhere, anybody. However, we cannot store our value digitally, and we cannot transfer value digitally. So you can imagine that in the digital world, like metaverse, you cannot preserve your digital asset. You cannot transfer your digital asset, or we can do that in some way, but it's not safe. It cannot be guaranteed. You cannot trust the system. So blockchain can serve the purpose. We'll talk about it later. But basically, I think digital, when we talk about integration of the physical world, integration of the human, we also need to see what else are not digitally connected, integrated. I think value is one of them, and blockchain can serve the purpose. Okay, or blockchain type of technology can serve the purpose. So as I have already discussed, with IoT, allow us to gather data from the physical world so that we can try to analyze the data and help human or system to make better decision in the physical world. It will help us tremendously in managing the physical world if we can get data from the physical world. So IoT provides this infrastructure. The data collected may not be used directly. As I said earlier, we have the most powerful sensors, which is camera. Camera capture a lot of information at one shot. And if we have video, it records a lot of information, even more information, a lot of information that only human can record. However, computer cannot process them. Maybe, okay, again, without deep learning, imagining in the past, you have a lot of picture in the database and you ask the database, can you find the picture having dogs? They cannot. Or can you find the picture having warm feeling? Maybe they can by the color, right? But can you ask the database, can you find all the database having 3 dogs in the picture? They can. These are pictures. These are unstructured data. Like they are just pictures there. You can label them. If you did not label them, you cannot utilize them. And you need human to label them. So it doesn't work. Those are just record. And all of them require tremendous amount of human to process them. Video is even more complicated. By the way, we are also doing a video processing right now. But so for AI, for deep learning, basically it's a classification tool, basically. Classification tool, but your question could be more complicated. So basically it can serve as a tool to convert unstructured data to structured data. Now this picture has a lot of information. You run, after you build up the deep learning model, you run through the picture. The model can tell you how many dogs are there, how many cats, are they sitting or are they standing, how many men, women, all kinds of things, right? So that make those pictures having structured data for us to do, say, quantitative analysis, more sensible analysis, supporting our decision. So IoT is just the infrastructure, connected physical world with the digital world, but we still need to have the ability to process the information more effectively. Deep learning or AI tool help us to do that. A different AI tool support us to different improvement, but deep learning help us to convert unstructured data to structured data so that we can analyze them more effectively for decision support. And also data collected from the physical world, then we don't have proof. We don't things appear in the physical system. If you don't record them, they just disappear. They are gone. There's no trace, right? Maybe there's trace. But then if you don't record them, then it just passed. They're just gone. And now you said, here's this data. Let's validate whether or not it's correct. You cannot, because it has gone. It has moved to the next stage, next place, and you cannot validate that the data that's stored is correct or not. So you need to safeguard these data, make sure that these data cannot be changed, and also beyond that. So blockchain is this trust machine, recording such data, and it cannot be changed in all practical senses. Of course, in the future, maybe with quantum computers, it can be, but there will be something more like quantum encryption or other tools allowing them to be still be safe. But anyway, with the data, we need to make sure their integrity. With data with the integrity, then we analyze it, then we can support our decision. That provides a so-called intelligent Internet of Distributed Autonomous Thing. That's not, this phrase wasn't invented by me, it's by IBM. They perceive that combining IoT and blockchain, you will have this intelligent Internet of Distributed Autonomous Thing. It's intelligent. I think maybe without AI, we can already say that it's intelligent because everything is based on data, based on proof. Internet connected of distributed autonomous thing. So objects providing data, their data can be trusted because of blockchain. And blockchain has this distributed nature. So altogether, they present a intelligent Internet of distributed autonomous things. And I also call this a data-driven approach of all the decision problems. Data-driven approach. Maybe you can think of it. If people ask you, can you tell me, everything smart. So what does it mean by smart? You can think about it. Everything is smart. If you want to say, oh, I have a smart watch, I have a smart pen, I have a smart cup, and think of what kind of application you will generate, what kind of smart cup you will design. Chances are you will come out with something that has sensing capability, that can provide data for you, that can adjust to the environment, that can connect with you, and so on. All these functions related to smart were provided by the structure that we have just introduced. Okay, I also call this digital fusion. Combining these technology, they can enable a lot of innovative applications and service, which is something that we are doing or we have been doing for some time. Okay, so those are very long introduction. I'll quickly go through the development of IoT. First of all, the development of IoT is just like, again, for a lot of the young students, you may think that, well, okay, what else? I mean, it should be like that, but it wasn't. In fact, a lot of these electronic products or semiconductor products, these were extremely expensive and very bulky. And over time, through the Moore's law, in 30 years, a component which costs $1 million US, in 30 years, it becomes $1 US. That's the difference, 1 million to 1. So lots of technology may exist long time ago, but just because of the cost, they cannot be implemented, cannot be commercialized because it's too expensive. So Moore's law really supported this development of IoT. In fact, the concept of the having these IoT was proposed by somebody 30, 40 years ago. And at the time, of course, again, nowadays you probably don't feel that there's any surprises. But at the time, computers were so bulky, so primitive, but they were already people perceiving that in the future, in our environment, it will be filled with computing power and connectivities, so that we can interact with our environment. Environment can provide information to us. It's called pervasive computing or ubiquitous computing. Those terms were around for a long time, but it was just concept because too expensive, too bulky. It's not possible. There was also something called Nbn Intelligence in the background. So in the background, we'll have this kind of computing, sensing capability, and also communication capability. But again, very, very limited. We can have very fancy place, may have some sensors sensing, having motion sensors or a light sensor, very bulky and very expensive. Those are Nbn Intelligence. But now it's very, very inexpensive and very, very tiny. We'll talk about how tiny they are. And also wireless sensor network. Wireless is also a very amazing part of our communication, right? How can we communicate wirelessly? How can that be possible that we can communicate wirelessly? How can sensors stand alone, sensing information, can effortlessly communicate the information to network, to the server or to the cloud? It's amazing, but we can do it now. Okay, so IoT cannot rely on all physical connectivity. It does rely on wireless communication. Otherwise, it will still be too expensive. But now there are many wireless communication technology supporting all kinds of communication and again, connectivity. And there was this M2M concept, which is about machine communicating with machine. For not just connected, they communicate for a purpose and communicate, cooperate for a purpose. That is the point. And when IoT just came out, I think the most popular technology was wearable technology. It's very easy, very relevant to humans, so people can feel that, oh, I have something wearable. I have activity tracker, so it's like a bracelet, or I have something small connected with my body, sensing my body. That was very popular in the beginning of IoT, but the industry at the time was still struggling, finding a key application to support the development, meaning that you have this activity tracker, which is maybe $200 telling you how many steps that you walk, or your body temperature. It's too expensive. It's very difficult to use such kind of technology to create a sustainable business model. So after wearable technologies, gradually people are trying to search for different IoT application so that they can provide significant value, and so that there will be business model to support its development. I would say that cyber physical system, which came along with Industry 4.0, could be the key development. The concept can still be applied for different industry. Cyber physical system become cyborgs, cybernetic, like human, like having human intelligence, like having a digital brain. That's what it means. We have a physical system, but it become a cyber system. So physical system, we are not talking about activity tracker, one sensor, and sending information. We are talking about a complex hardware having a lot of sensors communicating among themselves, having ability to make decisions and working together with other systems, from small to huge system. Okay, although cyber physical system was created, again, along with the Industry 4.0 as the fundamental technology of Industry 4.0. But if you break it down, it is just IoT. IoT infrastructure, collecting data, communicating data, and with computing power and with a data analytics power, so that it becomes a cyber physical system. Okay. So that's a very brief history of IoT development. But the beginning was RFID. So RFID was developed to replace, I think you can imagine, to replace barcode. It was heavily promoted by Walmart, because Walmart, as a physical retailer, as the largest retail company in the world, and I think 3 of the children of the founder became top 10 richest people in the US. So it's a very profitable company, but it's retail. It's selling very inexpensive product. How can they generate their profit? It's based on how they manage their entire logistics. So in order to further improve on their logistics, they promoted RFID technology. Just in case you don't know what, I think probably most of you do not know what RFID technology is. So I'll introduce briefly. Radio frequency identification. It is a tag, right? Just like any kind of tag, but it has radio function, RF function, and it has a chip. Chip can store information. So RFID chip just store ID, an ID on the chip. But in this particular case, it is a passive tag, and it is a so-called ultra high frequency RFID tag. So you can use a reader. If all of everything has this tag, the reader can send the RF wave, and through the antenna convert it to electricity and read the data in the chip. And using the remaining electricity, convert it into wave and send it magnetic wave and send it back to the reader. So instead of scanning every barcode, you just read. You can read all the text in the environment. So you can imagine that how much more faster that you can do inventory counting, or you can check your inventory, or all the activities of the object with RFID tag can be tracked. Right? It's wireless. You just have the tag. Or right now, a lot of cars, like in Taiwan, we have this easy car. This car. This is also more or less an RFID. If it doesn't write information inside, it is a RFID technology. So we can read and it record information, or just having an ID information is recorded, in fact, in the back-end database of the company providing the service. So with this tag, it significantly improved the logistic, the efficiency of logistics. And RFID has different technologies. They have low frequency, high frequency, ultra high, and microwave. With different technology support different kind of applications. For example, you go through, if you have this easy car, it has my identification, and I can use it for payment. Okay, the payment, in fact, I'm not 100% sure about how it is for this, what kind of mechanism they do, but basically the card should just record in the minimum an ID. Every time you just use your ID to do any kind of transaction, and all the transactions were done in the back end. Okay, but you don't want you carrying this card, walking on the street, and suddenly some reader can read the information and do the transaction. So for this kind of card, the reading range should be very close. You need to be very close so that they can read your card and do the transaction. But you do inventory counting, you want the reader to read the entire shelf and get the information immediately. So you need to have a wider range, and you need to be able to read a lot of information simultaneously. So they have different technology, combination of technology, allowing different needs of different application be fulfilled. And here is a more practical case, just very quick. We have a so-called item level tag. Every bottle has one. So you need to think of the process of these bottles so that you will design the tag. There's a box level because the box usually goes to conveyor and so on. So it has this design. Or pallet, right? Pallet goes to different process. So you can design your tag differently. Usually these tags do not exist on its own. It will be combined still with barcode, just in case that you cannot read it. You can still use barcode, or just in case that you are out of electricity, you can still read. So there's a printed information, a printed tag, and also usually there will still be this printed barcode. But between papers, there's this RFID tag, so that you can do all kinds of logistic operations based on their needs and their design. This will be a case. Right? You go through the conveyors, and at different points, you can read the RFID tag. And when it comes out, this may be a pallet on an AGV. So the AGV with a pallet reading the information, the tag on the pallet, will be able to deliver to the truck. And the truck go to reaching the new destination, and the pallets will go in, and it will be read, and all the information within can be combined, and step by step, all the way to the retail, to the shelf, to the inventory, to the checkout, RFID tag can be used. So it will significantly improve the efficiency of processing all these physical products. This is the beginning of IoT, because people developing RFID technologies thought that now all the things can be connected online. Right? All the entities in the physical world, their ID can be recognized and can be checked to the digital network. So they call it Internet of Things, just to say that these things can be connected online. They are not physical objects lying somewhere and we don't know where they are. We can always read and check, oh, these books are in this room. Or even for human, we can just have, if every student has an UHF tag on their clothes, then we can just read. So student come in, go out, we can all know. Right? So things are not offline anymore. Things can be online because through digital system, we can access where they are. or maybe yeah, their activities. But then there are a lot of application. RFID right now is still very popular, but again, for the purpose of application, we need to find the suitable RFID technology. We don't need to do it all the time. Okay, so let me see. I'm not sure why. Sorry, wait up. 是。
你好，我是台北市政府卫生局资讯室于淑媛。
哎，我不能讲话，我在上课。Sorry, there are just a lot of phone call coming in. I'm not sure whether or not it's important or not. Hello?
Yes, sir.
Yes, Prof, you can go.
Yeah, sorry. Because the school keep calling me. I'm not sure why. Oh. Sorry. Give me 1 minute. Sorry, because the vice president called me. Keep calling.
Okay, sir.
That's all right. Perhaps Pak Indi have the video that can be played.
Oh, maybe I can explain about the syllabus for the
Okay.
this class. Okay.
Okay, that's all right.
We have the exam and mini project. Maybe I can share with you.
Yeah,
Okay.
thank you, Mas.
This way.
Thank you, Raras.
Can you, Bu Raras, ini sharingnya saya nggak bisa nge-share.
All right.
Sudah, Mas. Sudah saya
Sudah, ya?
multiple.
Okay, thank you very much, Bu Raras and Professor Erma. While Professor still need to take phone call, so I will explain about our courses in here, our course. Okay, so this is Bu Erma already explained that we have 4 meetings for this course. The first one today is about fundamentals of Internet Things, and the second meetings will be held on May 12th, because we will have Idul Fitri holiday, right? So yeah, we will start again after the Idul Fitri holiday. So we will continue on Thursday, May 12th. The first professor will explain about IoT application with data and analytics. Then I will continue with some demo presentation about our development on activity recognition for clean room SOP, standard operation procedure. And then the third meeting will be held on Thursday, May 19. Professor will explain about the data integrity to innovative business model. Then I will continue with some demo about application that we already developed for the smart dispenser and then smart campus application. And then the last one, the week 4, we will have on Thursday, May 24th. This is on Tuesday because Professor on Thursday, May 26th has a meeting in Europe. So we will help earlier on Tuesday. So this is Professor will talk about Industry 4.0, and then I will continue with robotic mobile fulfillment system. Now we still focus in develop the simulation for robotic mobile fulfillment system, or maybe you may know is as Amazon Kiva Robotics. And then we also have some research and also collaboration with Professor Elma about the energy modeling. Yeah, this is more about the renewable energy and energy building. And then we will have exam because we need to have some score for your certification. On after the demo, only 30 minutes from 5 p.m. until 5:30 p.m. Okay. Then beside the exam, this is the demo. It's not only me, but several students, our student from, mostly this is from Indonesia and one student is from Germany, will explain about all the presentation or the demo. Actually, during this demo, you may also ask question and we can have some discussion. Okay, then and then the next one is mini project. So you can create some presentation, this one, about some application of IoT, can be healthcare service, logistics service, transportation, maybe smart factories or smart enterprise, smart city. Okay, on all mini projects should be as close to market and practice as possible. Yeah, and in mini project that you need to submit, it need to include synopsis or the case background and topic, and then case description, then the proposed solution and case analysis. Okay, you can make it in the PPT file, around 10 to 15 slides with necessary supplementary materials. And then you can submit no later than May 29, 2020. I will give the link for submission. And then the mini project should not be a presentation on academic paper, but we hope that you can get the idea from yourself, from your daily life. And then maybe you can have some solution to improve the quality of life or based on the problem that you facing every day. Okay, then this mini project can be done by self-organized group. Each group can consist of up to 5 students. Okay. Then the last one about the exam. This is the material is from course slide and discussion and open book, and then multiple choice question, mostly from the professor presentation. On an exam on Google Form, I will give the link in the 4th meetings. Okay, I think that's all from this one. If you have question, we can discuss later. Okay, Professor, are you ready?
Thank you, Mas Indi.
Yeah. Oh, Prof masih ini ya?
Yes,
Okay.
yes, I'm ready. Sorry, terribly sorry about this.
It's okay, sir.
No problem, Prof.
Because there's of course there's a pandemic. I'm not sure whether or not it's related. Because that vice president is in charge of this pandemic issues. There's one time that in our lab there were students suspected being infected early on. So that anyway, so it's okay now. I can continue.
Yes, please,
Thank you,
Prof.
sir.
Okay, so this is in fact something that we developed when the RFID just came out, and it is basically to track object for medicines. Some of the medicines are controlled medicine, so you need to be sure that they are still on the shelf at the right place, and when people want to pick them, they will not pick wrong items. So this is a smart shelf that we developed, and this is again also for the medical purpose. This is for stent. You know, when your blood you have blood clot, you need to put a stent in and stretch out the blood vessel, allowing the blood to flow again. And it's very difficult to manage such kind of stents. They are very expensive, but they are all very similar. So they have also in the hospital, they want to build out this technology. And we also use RFID to build up the system to support their application. And this is the third one. This one is for the so-called scientific Chinese medicine, because Chinese medicines are herbal medicines. So they are from different vegetables, vegetation plants. But usually they will be dried up and ground into powders and put into bottles. So when you need to have certain prescription, you'll take a combination of these powders and make them into different dosage for patient to take. But they are very similar. It's very easy to make mistakes. They can be misplaced. So this is also designed and built up by us. We physically behind each bottle, there's a RFID tag. So when you take it out, the reader cannot read it. The system knows that we have taken out which bottle. And this bottle will be placed on a scale. So on that scale, we sort of measure how much content it still has. So when you take it out, scoop out a certain amount, when you put it back, it will compute the difference in knowing whether or not we are taking out the right amount. When we finish mixing the medicine, we put the bottle back to their original places. Only if we put them back to the right place, the light will turn off. So that we will put them back to the right place. So it is a system fully utilize the function of RFID, allowing anybody not knowing where they are can easily, through the guidance of the lights, through the scale, and properly prepare for the medicine. So this is all something we build. So technologies are available, but in order to utilize the technology to create viable application, you need to understand the difficulty, the gap, or the pain point, and utilize the technology to overcome the pain point or the obstacle, so that the system can truly provide service for different applications. And these three are all used in the hospital for some times, but because we did not commercialize them, so those are just proof of concept projects. And the reason that we can have all these sensors small and put them everywhere, I think for those students who are from the electronic engineering department, you probably know this already. It's because we have this so-called micro electromechanical system. We know that electronics can be very small, but we don't know that mechanical parts can be very small too. Mechanical part can preserve physical properties. So, for example, if you have so-called gyroscope, usually in sailing or in airplane, they have this gyroscope so that it will reflect the gravity, and it will reflect your orientation, so that when you are lose weight, flying at high speed, you can still know that you are facing up or down, away from the ground or facing the ground, right? They are usually big, and for human to look at them directly, but you can make them very, very tiny and put them together with the electronic product so that it still serves the purpose and it communicate with the electronic system. So MEMS provide a lot of sensors that we are currently using in many devices. Later, I will show you in smartphone, we have many MEMS sensors. Okay, so semiconductor industry, usually they produce computing components, storage components, communication components. But in recent years, with the development of RFID, with the proliferation of the functions required, MEMS becomes another kind of semiconductor chips that are heavily required by all kinds of systems. So with MEMS, with the rest of the computing power, now we can easily create a lot of sensors placing in all kinds of devices, making these devices smart. Of course, there are also biosensors, which has the similar effect. A biochemical process will change the conductivity of liquid, allowing the change, trigger the connectivity, and allowing the electronic system to work, okay, to communicate. So communicate information, basically. So these sensors allow us to gather information from the physical world, and so that in return we can analyze the condition in the physical world and provide a suitable action or counter action. And wearable technologies, there are all kinds of wearable technologies. Sensing your brainwave, sensing your activity, sensing your body condition, sensing heartbeat of unborn baby, sensing the thigh muscle changes, sensing the movement. This is a ring, sensing the movement of your finger. Or this is something putting behind your shoes. You will track your footsteps, how you walk or how you jog, and provide such information for you to improve on your running behavior. Okay. Or putting this contact lens. This is also I think built by Google's. This is contact lens, and it has this sensors, biochemical biosensor and antenna, so that it will detect your eye drop liquid to test your glucose level. So people having diabetes can wear this kind of contact lens to know its body conditions. So these are very popular, but very relatively expensive. A lot of them were built, but not all of them are popular anymore. Okay. And there are also interesting sensors. These sensors are, in fact, John Roger is the leader of the group. They make many interesting things. Here is the kind of sensor, the tattoo kind of sensor that they built. For the first one is UV sensor. It can detect your UV exposure. So you put it on your skin, and you can constantly read the reading using your smartphone or other devices, so that you know that you may need to get away from the sun. Or perspiration or biochemical sensors. Again, it can detect through your sweat and understand your body condition. Or a blood pressure sensor. For John Roger, they'll even put something called piezoelectric electric sensors. They have this elastic materials, and when they are contracting, they generate electricity. So they put this on the heart of animals, so that when their heartbeat pump, then it generates electricity, allowing sensor to sense the situation and send the information. Still can send the information back. So it can be put on the pacer for human. When I saw the demonstration, it was placed on the pig heart, but their intention was to put it on the human. human heart, so that you don't need to when you have a pacer, you don't need to open up your body and change the battery from time to time. You can just rely on your heartbeat to pump the electricity using piezoelectric materials. And also all kinds of wireless technology. When we say wireless, we are talking about not telecommunication wireless technology. We are talking about more like personal area, a local area, or there's also so-called wide area. Wide area is not too wide, but then wide area wireless technology. And we have a lot of such kind of technology already supporting IoT applications. And particularly for IoT application, because a lot of sensors are tiny and having very specific functions. It doesn't need to transmit the information too frequently. So it's not possible to use Wi-Fi because it's too expensive, way too expensive. Even for Bluetooth or Zigbee, it's still too expensive. So basically, they quit. I think maybe 5-10 years ago, most of these technology were developed by in France. For example, Sigfox, LoRa, all of them were developed originally in France. Anyway, they are so-called low power wide area network. Low power wide area. If your sensor only transmit information every 20 minutes with minimum amount of payload, then you can allow it to transmit a long distance. Okay, so the technology can cover a wide range of the sensors, but cannot process too much information at the same time. So the application scenario will be all these sensors, many sensors, they don't transmit a lot of information and they don't transmit information too often. Then they can adopt this so-called low power wide area network. The most popular one, which was promoted by IBM, was LoRa. And there was another one, as I said, is Sigfox. And these are unlicensed band. They are also licensed band LPWAN technology. It's called Nbn Iot. It is a licensed band. So a lot of companies using their existing telecommunication company using their telecommunication bandwidth and allowing some of them being used for Nbn Iot, okay, Narrowband Iot. So, again, as I said, with the sensors, you cannot connect them all the time. You cannot connect all of them. It's just not physically possible. They are everywhere. And so you need to allow them to use wireless communication technology. And this wireless communication technology has their benefit, but they also have their constraint. So based on the application development, gradually they feel that they need to have this LPWAN for certain kind of application. Okay, these are developed specifically for IoT application. And also for the communication, they are also the network communication. They also have different kind of protocol being developed, allowing we have a unified communication environment. But there are different standards for different industry. Right? For manufacturing, if we want to do wireless communication, we want to transmit data, we want to have a unified environment in manufacturing, machine-to-machine communication. There were many different kinds of protocol, but now they try to come out use this so-called UPC, Unified Architecture. Right? So for typical application, we probably use web services. For telecommunication company, they want to expand their service to IoT, they may adopt this called one M2M. For very critical application, requiring very low latency, very high speed transmission, there's also this called distributed data service protocol. All of them can address different needs of different industry or for different commercial purposes. Okay. So basically, for IoT technology to support application, we still need to allow them not just physically throwing digital information around. We also need to allow them to be able to communicate with each other. So we need to adopt certain framework, adopt certain protocol, so that the communication can be seamlessly. And with the our smartphone, in fact, we have many MEMS sensor within. Right? I think we sort of know that there are a lot of sensors, and we sort of know that these sensors are providing certain functions, but we may not be aware how these sensors were created and how they serve the function. But they are, as I said, they are MEMS. So they are basically a combination of tiny, micro or nano, not nano level, could be nano level. They are nano robot too, right? Very tiny physical object, but it still preserves the physics as it physical phenomena as it in the physical world as if it's big. So for example, gyroscope I mentioned, as long as there's a gravity, your gyroscope will just follow. You move, but it will still pointing at the direction which is the ground, right? And you can know the angle in all the direction. There's the accelerometer, right? Accelerometer when you are moving and when you stop abruptly, you will continue to move. And the way it moves, its displacement can be used to compute the change of the speed. And that information can be fed back to your digital system and used to control the device to react to that situation. Right? A pressure sensor, haptic sensor, and fingerprint sensor, and so on. Those are all kinds of sensors, all kinds of MEMS devices in the smartphone. They are all chips supporting different kinds of application. And in fact, smartphone is really a very amazing device. Over time, I have tried to develop many applications related to human, helping human. But in the past, the biggest problem is who will spend that much money buying a very sophisticated device just for one function? The answer was probably very few. But now we have a super powerful device with us. So all kinds of application can be enabled. This device can link the person with the entire world, right? All the resources, all the computing power in the world. And it also provides a lot of sensing capability, allowing users to understand the physical environment about the human and the surrounding area and provide the information again, for the remote system to provide proper services. So it's a very incredible device. It's you can also consider this as a super powerful end node of IoT. It is for communication. It is also an observer of the human and also the environment around this smartphone. So it has enabled many innovative applications. And if we put everything in their places, basically we can say that if we want to talk about IoT architecture, I mean, when we talk about IoT, we can think of it from different perspectives. Here we are looking from the architectural perspective. That is, we from the endpoint. So we have sensors everywhere, sensing the environment or observing the environment, gathering this information, and to the local like personal area network, local area network, or wide area network, getting this information. These are different network systems. These are not the TCP/IP environment. This information will be gathered to gateway. Through gateway, we can go to different network system, right? Telecommunication system, right? Ethernet system, all the kind of system. And this network bring this data to the cloud, where application and utility functions are. So with IoT, what we can think of is we'll have sensors anywhere, everywhere. Sensors, not only on our phone, sensor in the room, sensor on the car, sensor for security reason, right? For air quality reason, right? For energy saving reason, right? We have sensor everywhere, and they will be connected anytime, so that we can provide service intelligently. Service in the physical world, we can provide intelligent service in the physical world. Okay, so that's the at least early vision of mine on the IoT. That is, we have all the sensors everywhere, and they are all connected, bring the information to the cloud, and they have supporting function, utility function, and they have many applications. And of course, there are a lot of solutions like this already. A lot of solutions being created on the cloud side. They are platform, right? They are PaaS platform as a service, allowing you to quickly ramp up your applications. They are SaaS, software as a service. They have a lot of software there, so that you don't need to build your software. You can just have your niche core application combining with other service. Then you will be able to provide your service. So the environment is gradually more and more mature. And I mentioned earlier, it does require our ability to handle the data. We need to store the data, manage the data well. Then we need to be able to analyze the data, right? Analyze data. And furthermore, we need to be able to obtain insight from the data so that it will benefit the application. So IoT, if you only think of this infrastructure, it's just connectivity, just like when you say network. So okay, network, connect everything. It doesn't seem to have any big application. But without network, all the application cannot, a lot of the application cannot be realized. Similarly, IoT, without data, most of the the smart application in the physical world cannot be realized because we don't have data. We don't know their status. We don't know their process, and we don't know how to intervene and help them. Right. So basically, IoT should have ability to collect data, but we need to be able to analyze it. And this analysis will result in insights so that we can benefit the application. And of course, with IoT becoming more proliferated, then in fact, it's not just cloud, because we are connecting so many different things together all the time. So the connectivity becomes the bottleneck. So we need to be able to handle this massive amount of communication and computation. So instead of having this so-called cloud environment, which is somewhere far away, huge, there's also something called fog computing, or I think people also call a different computing separated from cloud, which is edge computing. Fog computing is basically a surrounding computing environment. So we have communication, but communicating smartly, and we have computing power, but computing power doesn't have to be in the cloud. All of them in the cloud. They can be in different stages or locally, and which is a combination of edge computing and cloud computing.
I'm sorry, Professor, because of the limited time. So this will be the last slides, and then we will continue to the questions sessions.
Okay.
Right.
So different IoT devices can be connected together to support each other, to result in a viable or feasible application. And maybe the last point is the application need to solve problem, need to be able to solve the pain point, need to be suitable for adapting the application situation. Otherwise, it will not help. And this is a very good example that I like. If you put the sensor on a kid, the kids may tear it off, but you put it in pacifier, the kids will continue. Even you want to take it away, the kids will still put it back. So this is a very good design of the IoT product. So with this, I yield the time back to Raras. Thank you.
Thank you so much, Professor Chou. So we have around 6 questions here. I will read the first question. Is from Mirza Aditya Badarudin. His question is, considering the extensive application in IoT in everyday life, what are the plans for developing IoT in the future?
Okay. I think right now the IoT development, the biggest problem is most of the development cannot, right from the beginning I mentioned about this, cannot generate substantial return. So it is still quite costly. My feeling is right now for each application we generate an infrastructure. The best way is we generate infrastructure just like telecommunication. It supports many applications, but because they are still separated, very fragmented, so individually they are still too expensive. But if we can sort of combine them together, building up a integrated IoT system, the same system collecting data, supporting multiple applications, then I think IoT application will be more sustainable. A lot of POC was deployed, proof of concept. A lot of proof of service have already been proven. The so-called proof of business, that is, it generates profit to sustain by itself, still a big problem. Okay, so that's something that we need to think about. But where is the point? I'm not very sure. What I can see is they are all separated. They need to be integrated together so that each originally separated infrastructure can support more applications. Still a cost issue.
Yes, still a cost issue.
Right.
All right, so next question is from Livran. Livran, please, can you answer it directly to Professor?
Yes, ma'am. Okay. Hello, everyone. Hello, Professor. Thank you for your presentation. It is so insightful for me. I want to ask a question for you. If the IoT has been applied to some of the things around us and they are connecting and transferring data each other, wouldn't this will be dangerous because when one of that things got hacked by someone, it can give us more negative impact because there are probabilities to hack other things using the connection between them. Is it possible to happen, or the IoT has security system itself? Thank you.
Thank you. Yeah, it is a very critical issue for IoT applications. I think any kind of, for IoT, the biggest problem is it's the security level was very, very weak. So it's not like our current IT system. We say, okay, we put a gateway there, and we have a secure gateway, so we can secure the environment. IoT devices are just out there everywhere. So there are a lot of development using different kinds of mechanisms, including combining blockchain, so that we can authenticate the sender and authenticate the information so that we can respond correctly. For example, if your system depending on the sensors data and to respond, if the information was sent by some malicious source and then they are sending you wrong information. For example, they say, oh, it's not, temperature is not high enough, so your air conditioner keep increase the temperature until the level that it may create harm, then it's very dangerous. Right? So there are a lot of development in this regard. But this is also something I don't think it will end, because you are only better than your hacker. Right? When hacker become better, then you need to improve again. So it is an area. We are running a workshop with Tokyo Institute of Technology on IoT, intelligent IoT environment, and every year in the presentation, they were probably more than half of the discussion were on IoT security. So that is something we need to be very careful. I need to address carefully. This is also the reason that a lot of manufacturing companies do not want to use it. They don't feel that it's safe. They don't want to use wireless communication. They don't want to use high-level programming language either, right? Because robustness for them is more important than a lot of other things. So these are all issues that we need to address. Meaning that we haven't solved the problem. We haven't solved all the problem. But there are a lot of development ongoing, just like the current cyber physical system. And we need to be aware that security issue is a main issue. I can only say that.
Okay, thank you, Professor.
Sure.
Thank you, Livran. For the third question is from Ms. Nuraini Rahmawati. The blockchain dismisses central storage. However, a ledger must be stored on the nodes. How do we deal with such a situation? As we know, an IoT device has a very low storage capacity.
Oh, okay, okay. So again, this you can, in terms of compute, in terms of this, we are not saying that this is a node sending information. It is just that this node sending the information because, for example, very simply, using private key, public key pair. Of course, it exists already, but then blockchain also has this function, right? So when you send the information, you you hash it with your private key, so the reception party can use the public key and make sure that it's you who send the information. So authenticate the sender. So that's just saying that with blockchain system, it has this function among other functions which can support IoT system. It's not to say that on IoT infrastructure, we want to build a new blockchain system, having all the nodes performing the node function in a blockchain. Hopefully explained partially, meaning that we are utilizing blockchain or blockchain function, but we are not superimpose a blockchain system on top of the IoT infrastructure. We can still utilize the traditional IT infrastructure to validate the information. So your IoT device is just like a device having a wallet. Just like human having a wallet, I can go through the blockchain system for all kinds of transaction. But it's not that I do the computation for the node. We are the users. IoT end devices are the nodes. They are not the. We are the users. IoT devices are the users. They are not the nodes. Did I answer your question?
Budaras, may I?
Yes, please.
Okay, thank you so much, Professor Chou. Yeah, so what you mean that so we don't have to store the ledger in the IoT device, is that right? Or I mean the ledger could be in somewhere servers or something.
No, the ledger is not stored in IoT device. Ledgers, so-called ledgers, are storing on the IoT, blockchain system, meaning that the nodes duplicate nodes, and it is a different infrastructure which can be used by, say, human or companies, right? As long as we have a key pair, our address, which is the public key, and our which is our wallet, and our identification is our private key, right? So human are users of are the users of the blockchain system. Similarly, IoT devices are users of the blockchain system, utilizing the blockchain system for authenticating their information, their identity, and if necessary, authenticate their information. Right?
Yeah, okay. Thank you so much for the answer. So so the IoT device only store the e-wallet, right? So not the ledger itself. Yeah.
It's not
So
right.
yeah.
It's not
Okay.
IoT. It's not blockchain. Yeah.
Yeah. Okay. Thank you so much.
Sure.
Thank you, Professor Chou and Bu Iin. So that is the last question. Actually, we still have 4 more questions, but because the time is limited, and for some of you who are preparing for breaking your fast, so we will give you time for that. So we will stop here, and then for the rest of the questions, we will discuss it in the next lecture. Is that all right? So thank you. So Belva, Aulia, Naufal, and Christopher, we will keep your questions and we will discuss it with Professor in the next lecture. So please, all of you join on our next lectures. It will be more interesting. So we will talk more about detail for the Internet of Things. All right, so if I make a summary for today's sessions, Internet of Things increases productivity, hopefully, and makes everyday life of many users in general more convenient, safer, and efficient. So this is a really great and important things nowadays. Okay, and I would like to thank you to Professor Erma Suryani, and then several lecturers in information system also joined today. We have Bu Nur Aini Rahmawati, Pak Nisfu Asrosani, Pak Izzat Aulia Akbar, Bu Retno Aulia Finarti. Thank you for joining. And I will see you all not next week, but next 2 weeks, because we will have holiday for the next week. Thank you, and let's take a pictures before leaving. So please turn on your video. Professor, could you please to stop the share screen?
Okay, sorry.
Thank you.
Let's see. Stop share. Okay.
Yeah. Okay, so I can see everybody's face. Please turn on the video. So I will have several screenshots because we have more than 100 staying until the last. Okay, so I will count for the first slide. 1, 2, 3. Cheers. To the next slide. 1, 2, 3. Cheers. Okay, the last one. Wait a moment. Last screenshot. 1, 2, 3. All right. Thank you so much. Thank you, Professor Chou. Thank you, Pak Indi. And have a good evening, everybody.
Yeah, thank you, Buraras. Professor Chou, thank you, Professor. See you next. Yeah.
Thank you.
See you next time.
Thank you, Pak
Thank
Muja.
you, Muja.
Thank
Okay.
you, Prof.
Thank
Yeah.
you.
See you later.
See you later.
Yeah.
Thank you.
Thank you, Prof.
You can leave first, Prof.
Bye, Indy.
Bye, Prof.